Hey everyone, so today we're going to talk about a web framework that, well, it disappears. It's called Svelte, and it's built on this really radical idea. What if the best framework is actually the one that never even makes it to your user's browser? It's a bit of a mindbender, so let's break down how this whole compiler thing is kind of changing the game.
Okay, before we dive deep into Svelte, let's just talk for a second about the frameworks we all know and probably use. React, Vue, Angular. They're amazing, right? Super powerful. But they all come with this, hidden cost, a kind of framework tax that our users end up paying without even realizing it.
So what is this tax I'm talking about? In one word, bloat. It's the entire framework library that you have to ship to your user's browser right alongside your own app's code. Just think about that for a second. Before your beautiful UI can even pop up on screen, the browser has to download, then parse, and then execute this big old library. That's a really heavy price to pay, especially when you're trying to make a great first impression.
Right, so the way it usually works is kind of like shipping a whole factory with every single product you sell. You send this runtime library, the factory, to the browser, and then it has to figure out how to assemble and run your code. But what if we just flipped that whole model on its head? What if all that complicated assembly work happened before we shipped anything? That's the core idea behind Svelte. It's a compiler.
And honestly, that's what makes Svelte's approach so radical. It challenges this fundamental assumption we've had for years by just asking a simple question. Why do we even need to ship a massive framework library in the first place? Why can't we just ship the exact JavaScript needed to make the app work, and absolutely nothing more?
And this is what makes Svelte so different from everything else. See, it's not a runtime framework at all. It's a compiler. When you build your app, Svelte takes your components and it just translates them. It turns them into these super optimized tiny bits of vanilla JavaScript. The framework itself essentially disappears, leaving behind only the leanest, meanest code possible for the browser to run.
The whole workflow is actually incredibly simple. You just write your components like you normally would in these .svelte files, mixing your HTML, CSS, and JavaScript all in one place. Then, when you're ready, you build your app, and the Svelte compiler does its thing. The final output isn't your code wrapped inside a framework. The output is the app, just lean, optimized, and ready to fly.
Now, this compiler approach unlocks another huge performance win. Svelte doesn't need a virtual DOM. Frameworks like React use a virtual DOM to try and figure out what changed at runtime, which is a clever solution, but it adds memory and processing overhead. Svelte just skips all that. Because it's a compiler, it can see at build time how your app might change, and it writes the perfect surgical code to update the real DOM from the very start. There's no guesswork, no wasted cycles.
Okay, I know, those are some pretty big claims, but the proof really is in the performance. This isn't just some cool philosophical idea. Svelte delivers real, tangible, measurable results.
Let's just look at the numbers for a second. This right here, this is the gzipped size of what's called a real-world demo app. It's a pretty complex clone of a social media site. Built with Svelte, it's a tiny 9.7 kilobytes. Now that same exact app built with React and Redux, a whopping 193 kilobytes. I mean, that's not just a small difference. Svelte is literally 20 times smaller.
And that tiny size translates directly into speed. This benchmark here shows the script boot up time, basically how long it takes the browser to even get the code up and running. Svelte is almost 3 times faster than React or Vue, and it's over 8 times faster than Angular. Less to download and less to parse means a way faster experience for your users, especially if they're on a spotty mobile connection.
And the story just keeps getting better when you look at memory usage. Svelte apps aren't just smaller and faster to start, they also use way less memory while they're running. This is huge for low-power devices, but honestly, it just makes things feel snappier on any machine. Svelte is just lean, all the way through.
So, okay, it's small, it's fast, it's super efficient. But can it scale? Can it really handle all the features you need for a big, serious production-level application?
This is always the question, right? It's what every developer asks when some new, lean tech comes along. Is this just a cool toy for side projects, or can I actually build a business on it? And the answer to that is a big yes, thanks to something called Sapper. Sapper is an application framework built by the Svelte team. It takes that amazing Svelte compiler and adds all the scaffolding you need for big projects. Need routing? No problem, just make a file in a folder. Want a fast first-page load and great SEO? It's got server-side rendering right out of the box. It even automatically splits your code by page. Sapper gives you all the power of a modern framework, but without that awful runtime penalty. When you start to put all these pieces together,
you realize something. Svelte isn't just another framework to add to the pile. It's a fundamental rethinking of how we build stuff for the web.
I think this quote from Svelte's creator, Rich Harris, just says it all perfectly. Instead of adding more and more layers of abstraction at runtime, Svelte's entire goal is to do more work ahead of time, so you can just get rid of code. And getting rid of code makes everything faster and simpler.
So this all brings us to one final, much bigger question. Is it maybe time to rethink reactivity itself? For years, frameworks have used all this complex runtime code to track changes and update what we see on the screen. Svelte comes along and proves that you can achieve true reactivity at the build step by just turning simple variable assignments into super efficient DOM updates. It makes a really compelling argument for a simpler and much faster web.